Today we'll be discussing the inspection of tank venting arrangements. Now, as always, safety is always our number one concern. So ensure that when we come out for inspection, we have all our proper PPE donned, and we're practicing good situational awareness, particularly if the vessel is fully loaded with cargo, to ensure that you're not in the presence of any of these venting arrangements should they choose to vent. At this time, we'll just get right into the material inspection itself. For this PV valve, you'll be seeing many different iterations of it, but in this case, and most cases, they pretty much all operate the same. They just kind of look a little different, depending on pressure, cargo, etc. But in this case, obviously, just take a general look, make sure there's no major corrosion or any major issues. We'll get into the flame screens a little more later, but you're going to be taking a look at that. One other thing to keep in mind, according to manufacturer instructions, every 5 years these need to be bench tested to ensure proper function. So you'll see 5 years from here, and then every 5 years thereafter you want to see a servicing tag proving that it has successfully been tested. And aside from just the visual and ensuring that the manufacturer instructions are being followed, that concludes the majority of the material inspection of the PV valve itself. Next, we're going to get into the actual inspection of the flame screens or flame arresters on the pressure and vacuum side of the PV valve itself. What that's going to consist of is just pulling out the screen, taking a look at it, just get a general idea of the condition, make sure it's not all gummed up with soot or whatever you may have there to prevent it from operating as intended. You'll see that if you hold up an open flame to it, flame will not be able to pass through. And that's pretty much proof that it's operating as intended, keeping flame from interacting with the vapors itself. So again, you'll be checking both sides. Just give it a once around and then just ensure that it is in good working order. Next, we'll get into discussing the verification of height of tank venting system itself, as far as where that system will be venting off to. On these barges, they're unmanned. There's not going to be people on deck as these are transiting. So it's not going to be as high as you might see on a tank ship. These heights vary according to cargoes, vessel type. So you'll see it varies a lot depending on what kind of vessel you're on. But the best rule of thumb is the more dangerous the cargo, the higher the venting system should be. Just as we have stated before regarding the height of the tank venting system, another thing we're going to be verifying is the horizontal distance from cargo tank vents themselves. Again, this is very variable according to cargo type and vessel type. So there's no one size fits all. There's no standard across the board. Depending on what you're on and what they're carrying will dictate, according to the regulation, how far those need to be. So again, in that situation, you'll have to gauge it before you go out, kind of know what you're dealing with, know what to look for. That's just something to be mindful of. So now we'll discuss the various audible and visual indicators that these vapor control systems will have installed to let you know that something may be going wrong with the vapor control system itself. On these barges, again, it's not going to be as much of an issue for something that you're going to be testing. But on these tank ships, it's something you can test for alarms for the presence of in the cargo control room. And the basis of all that is just monitoring the pressure within the vapor control line, whether that's low pressure or high pressure. Particularly on these tank ships, you're going to want to be able to monitor that and be alerted should something be going wrong. Now, another piece of equipment that you may run into while inspecting these vapor control systems, particularly on tank vessels, not something we can point out on this barge particularly, but what you'll see are blank flanges, or what they call spectacle flanges, coming out from the piping, leaving the cargo tank. And it's just as simple as being able to provide a worker on deck a visual indicator as to whether that's opened or closed. So next we'll briefly get into the set points of these venting systems as it pertains to the design standards of the tanks as far as the pressures they're able to withstand, both positive and negative. For this PV valve in particular, the set point is 1.5 psi on the positive and the vacuum 0.5 psi. So to generalize, with the vapors and everything these cargoes emit, And with the changing temperatures outside and inside, the cargo tanks need the ability to breathe. Because if pressure becomes too far in the negative, the tanks can actually compress in. And if it becomes too much, obviously they can pop. So the set points are very important, and these PV valves ensure that those allotted ranges are met at all times within the tank. So now we'll get into verifying the operation of vapor line pressure sensors and alarms. Obviously another important indicator to let members on the ship or workers know that there may be a problem with the pressure inside the line or in the tanks. The vapor line itself will actually have pressure sensors in there indicating whether it's high, low, low. You could take a visual look at the sensors themselves, but realistically the only way to verify that they're in proper working condition is to test them. So while you're on board these vessels, you can have any crew member of the vessel go ahead and test those, and you'll be able to get alarms to indicate each of those set points and be able to alert the crew that something may be going wrong. So now that we've already inspected the material condition of the PV valve itself, another thing that we're going to need to verify is the condition, not only the condition that it's in, but the material that it's made out of. Certain cargoes interact poorly with certain metals, so depending on what the vessel is rated to carry will in turn affect what material the PV valve has to be made out of. Just the vapors from the cargo alone, or cargo interacting with the type of metal itself, will corrode it more rapidly, or whatever the case may be. So this is something that usually shouldn't get missed in the approval of the system itself, depending on what the vessel is rated to carry. But that's another thing that you can verify should you come out and see that the PV valve is in poor condition. So to wrap up our list of inspection items for the tank venting arrangements, we'll go over some inspection tips or unique considerations to take into account. Obviously at the top of the list we started with safety. You need to make sure you're familiar with the cargoes carried on board, what they may be carrying at the time, because obviously the more toxic the cargo, the more in harm's way you may be. So you got to know what you're dealing with, and like I said before, if it's loaded, obviously the cargo is present, and more of a danger is present there. Back to what we discussed with the flame screens, those mesh sizes have to be within a certain amount, or down to a certain amount, I should say, for it to operate properly. A good little rule of thumb is the pencil tip test. If you could fit the pencil tip in, it's a good test to utilize. And then the vent base and connection to tank top. It's a common area for corrosion. As we mentioned before with the drain line, sometimes you may miss that it's there, or they never utilize it. We want to just keep in mind the corrosion, any weak points. Obviously we're dealing with pressure here, and any weak point is going to be exploited by high pressure. And at the end of the day, that's pretty much the major items you want to look out for. But at the end of the day, the number one priority always remains safety. So just make sure you're looking out for each other and are always aware of your situation. Now finally, to summarize everything we went over regarding the inspection of tank venting arrangement. To start, we identified all hazards, concerns, and PPE that should be worn while inspecting the tank venting arrangement. We discussed verifying the material condition, verified the condition of flame screens and arresters, verified height of tank venting system, as well as the horizontal distance from air intakes and openings. We verified operation of the visual indicators, verified the presence of blank flanges, verified operation and set point of pressure vacuum valves, or PV valves. We verified the operation of the vapor line pressure sensors and alarms, verified the material of PV valves is compatible with the cargo itself, and then we wrapped it up with going over any extra inspection tips or unique considerations. And as always, any other issues or concerns, go ahead and reach out to your VO.